Hey, what's going on, everyone? It's HVAC Jake here, and this is the Push Pull podcast. And I want to introduce you to my co-host, Julian Finbow.
Hey, I'm Julian Finbow. Yeah, longtime friend of Jake, former colleague for some months at Mohawk College, but we've always been back and forth on work and trade stuff. So yeah, just recently kind of decided to get together and start doing some episodes or videos kind of thing, and starting off by doing this podcast. So here we are, Jake.
Yeah, I worked at Johnson Controls for 14 years. I worked on many different types of equipment, from rooftops to heat pumps and chillers, air handling units. I did commissioning, VRF stuff. So I got quite a bit of experience on different equipment here. And actually, behind me in my screen here is one of the job sites I worked at, and I was taking the refrigerant out of the system here. So this is a train chiller, and I was taking out the refrigerant 123. And there's some of the equipment behind me there. There's the low pressure recovery machine, which is just a big vacuum pump essentially, with a few other components on there. And then there's a couple of tanks back there. We got two 550-pound cylinders, and we got 1,000-pound cylinder over there. So I was taking the refrigerant out of this chiller here, and I was using the push pull method. So today, me and Julian, we're going to kind of go over what the push pull recovery method is, and we're going to draw a little diagram on the whiteboard here and kind of explain how to utilize it when you're taking out lots of refrigerant out of a system. Kind of the rule of thumb is anything under 10 pounds, you would do a conventional recovery, but anything over 10 pounds, you can use the push pull method, and it's a lot quicker and a little bit more efficient, and also helps protect the equipment, especially when you're working on water cooled equipment, because you don't want to pull out vapor off the top of a chiller with there's water in there. You want to make sure you're going to protect the tubes inside of there, because once the saturated temperature goes below 32 degrees, that's the freezing point of water. So you have a potential for the tubes to freeze. So it's good to use the push pull method. So I'm going to pass it over to Julian. He's going to bring up the whiteboard here, and we're going to kind of draw out the diagram and just chat back and forth and show you how to do a push pull recovery.
Yeah, absolutely. So before I pull that up a little bit about myself, and I had a comment about something you said, Jake. My primary background is industrial refrigeration, so working on ammonia systems and industrial plants, and then also research and development equipment, so like compressor test stands, fabrication and operation of those. And yeah, so as far as working on chillers like the one behind Jake, I've been able to do that as of recently, and put this push pull into practice. And then Jake talked about R123. I just checked it out on the Danfoss app. That's the one that you can stare at, right, Jake? And you can like look at
Yeah,
it
I
in
believe at like 75 degrees Fahrenheit, it's 0 psi.
negative.
Maybe
All
punch
right.
that in. See what 0 psig is.
Zero PSIG.
Yeah.
Yeah, 82 Fahrenheit.
So if you were in this chiller plant and it was 82 degrees in there, you could have these bottles open to the atmosphere. It's at 0 psig. So this refrigerant mostly is in a vacuum, because room temperature is about 70 to 75. So this refrigerant will be in a vacuum. And these chillers actually run in a vacuum as well, on the low side. And on the high side, they do tend to get to that positive pressure, but they do consider this to be a low pressure chiller based on the refrigerant 123. So yeah, that's pretty cool.
Yeah, amazing. Okay, cool. Well, I'm glad you brought that up. I always think about that one. So, all right, just gonna start a new whiteboard here. You want to go straight to the push pull, Jake?
Yeah, let's start with push pull, and then we'll show the conventional method after.
Sounds good. So I'm just gonna draw some basic components here. I'll throw them in the middle, Jake, and then if we want to move over, we can. So this is going to be our recovery machine. I'll draw the chiller up top. I'll just do a rectangle for the chiller. Usually the barrels, you could say they are a rectangle, but you could utilize either barrel, right, Jake? You could do the condenser or the evaporator for this method.
Yeah, typically you want to pull the liquid right off the lowest point of the chiller to prevent any issues with potentially freezing the tubes. So we'll use this as a representation. We'll just show it kind of off the bottom of the chiller.
All right. And I'm gonna do my best to scale up the scaling is a little off on this, but this has got to be like between a 1 and 200 pound bottle. So we'll call this the recovery cylinder.
Yeah.
Because in this method, we're talking about push-pull recovery, as opposed to you can do push-pull and charging too, right, Jake?
Yeah, you can push pull with charging as well. Yeah.
All right, cool.
But we can go over both of those, and then we'll go over the conventional recovery method.
Good stuff. So if I got these components up here, we can also add in later, Jake. You can draw on the connections for water on the barrel if we want to talk about flowing water. But if you want, you can draw the lines in for the refrigerant hoses you would use to get this going.
Yeah, for sure. So typically when we're working on bigger chillers here, we have our 1/2 inch hoses. It just makes the recovery go a lot faster than your conventional, 1/4 inch hoses you'd see on your manifold. So I had a whole bunch of 1/2 inch hoses when I was out in the field there, and a bunch of fittings, different fittings. Some of the chillers had 3/4 fittings on there, even as well. So you'd have to kind of fit down there. But one key thing I will say about this is make sure you have a bunch of valving as well. You can buy 1/2 inch valves and also a sight glass. So I'll see if I can put that in here too, because you can really see the liquid coming out of the chiller. So what I would do is I would grab a 1/2 inch hose. I would start, and right off the bottom of the barrel, you're going to want to run a hose right to your recovery cylinder. So I would add a little sight glass.
If you want,
right.
Jake.
Sorry?
I can pull this bottle down a little bit for you, get it out of the
Oh,
way.
sure. Yeah. That'd be great. So I'm going to call this little bubble here sight glass. And I'll put a little text beside it. Sight glass. And I'll put a little arrow there. So the reason for the sight glass is so that you can see the liquid coming out of the so you're going to have a valve there and sight glass, and you're going to hook up right on the bottom of the chiller. Then you're going to take your 1/2 inch hose and you're going to hook it up to the liquid side of your recovery bottle. So I'm going to do another little note here. Or a little, I'm trying to figure out how to get the arrow there. It's backwards now. 1 second. Heat. I'm going to do an arrow this way. So you're going to have this is going to be hooked up to your liquid side of the tank.
Right. And while you're doing this, Jake, I'll color all the flow arrows through our recovery process in green, and I'll color the other ones to gray. So it's like a pointer arrow is gray and flow arrow is green.
Perfect. So that's kind of the first step. You want a sight glass there so you can verify when the liquid is out of the chiller. And that's a kind of a key point. So you're going to start with liquid recovery, and then you're eventually going to switch over to vapor recovery. So the sight glass is a good indicator. You can watch it. You can actually see the refrigerant coming out of the chiller right into the cylinder there. And then off the recovery cylinder here, you're going to take the vapor and you're going to go into your recovery machine. So I'm gonna put the little text here just to show this is the vapor side.
Yeah, that's good, Jake. And for those who think it's strange that we're drawing an arrow out of the side of the recovery cylinder, this style of drawing we're making represents like a PNID, which is a piping and instrumentation diagram. And it doesn't always have the correct location for lines coming off a heat exchanger or a vessel or anything like that. It's just a basic diagram that shows the flow. So that's why we're just going off the side of the cylinder, just for simplicity.
Yeah, thanks for clarifying that, Julian. So now what's happening is we're going to be pulling vapor off the top of the recovery cylinder, and we're going to use our recovery machine to move the vapor back into the chiller. So off out, so into the recovery machine from the top of the bottle from the vapor side, and then out of the recovery machine is going to go into our chiller. So if you're looking at this diagram now, the reason why we call it push-pull is because we're pulling refrigerant off the top of the recovery cylinder. So we're causing a low pressure to happen in our recovery cylinder. We're utilizing our recovery machine as a pump to add pressure to our chiller. So we're pushing vapor into our chiller and we're pulling the liquid out. So the liquid is going right into the recovery cylinder. And what happens is you can kind of do this until all of the refrigerant is out of the chiller, and we're just going to be circulating vapor throughout the chiller and the cylinder and the recovery machine. So at that point, when all the liquid is in the recovery cylinder, you're going to look at the sight glass and see that the liquid has been moved. It's all been moved into the tank. And at that point, you would close off the liquid side. So that's why it's important to have valves on every hose that you have here so you can valve this off. Or you can use the valve on the chiller itself. So I would close off the liquid side when you get to that portion of it. So I'm just going to kind of show that here maybe by going uh, delete. So what you would do is you would close off that valve. Now the liquid's all in the tank, and you would actually reverse these arrows, and you're going to be pulling out vapor now using your recovery machine. So now at this point here, your liquid line's closed off to the chiller. All the liquid is out of the chiller and it's back into the recovery cylinder here. And now we're going to get the vapor out of the system and pull the vapor out of the chiller through the recovery machine and into the recovery cylinder. And then once all the pressure in the chiller is out and it's in the recovery cylinder, then the recovery is complete. So that's kind of a basic introduction to the push-pull method on recovering refrigerant out of a chiller.
Good, yeah, Jake. Did you want to switch and throw some arrows on here for conventional recovery on this one, or do you want to move to a different diagram?
Let's go to a different diagram and maybe show a smaller piece of equipment, maybe just like a rooftop unit or something like that.
Yeah, okay. I'll close out
The
of
other
this one.
the
Whiteboard for
other
the
thing
next.
to notice here is we're not using any manifolds, right? And your standard gauges, where when you're doing conventional, typically you have a manifold and you're going to be using quarter-inch hoses or 3/8 hoses. So yeah, if you want to start the diagram beside there, that'd be great.
Right on. Yeah, and then also note that if you're doing conventional recovery, you don't necessarily have to use manifold gauges. You could go straight with hoses, depending on what other accessories you have for checking out your pressures or accessing your system, right?
Yeah, for sure. Yeah.
So one thing too, push-pull recovery is most commonly known, I would say, for chillers, like what Jake has behind him. But I also, in my world, in the ammonia world, because they're also big systems with thousands of pounds, tens of thousands of pounds of ammonia in them, push-pull recovery is used a lot too, right? You got to take 40,000 pounds of ammonia out of the system, like working at Simcoe Refrigeration, shout out, pump out trailer. It's a big box the size of my garage to pull the refrigerant out. So, and the other thing too, if you don't have liquid side glass, like when I did the one that I did on a chiller, like the one behind Jake a couple months ago, I didn't have a sight glass available, but there's a thing that we call the dancing hose. That when there's liquid going through a hose, it kind of dances. Kind of you can see the hose moving, and when there's no liquid, it'll just kind of sit there when vapor's flowing. So, Jake, you want me to drop the components again, and then I'll let you do the lines?
Yeah, sure. I'll just mention one other thing too is make sure you have some sort of scale so you can weigh the refrigerant out. That would also be a good indication if you didn't have a sight glass. Once you got all the liquid out, it's just going to stop recovering. So that's another point too. You can use a crane scale for some of the bigger tanks if you can hang it overhead and lift the tank up, or if you're using smaller recovery tanks like 250-pound cylinders, then you can just get like a floor type weigh scale. So it just depends on the tanks really. So Julian's drawing a rooftop unit here, a recovery machine, and I'll add in a set of gauges here. And we're just going to kind of go over the conventional recovery and just kind of show you the difference between the push pull method and conventional recovery.
Yeah, you can take it away on that, Jake, and I'll color the lines in as you go along.
All right, so I'm going to draw a little set of gauges here. Just going to draw a crude little set of gauges here, and it'll get the point across. Okay, so there's your manifold, right? And then what I'll do is I'll draw a couple lines here to kind of show the manifold hook up to the system here. So on the conventional method, you're just going to hook up to your gauges on both sides of the system typically. So you're going to hook up to your liquid side and your vapor side. So your gauges will be hooked up this manner here. So let's go to here.
If you want, Jake, I can color the gauges and hoses appropriate, blue, red, yellow, and then that'll
Yeah,
be
that'd be great.
all right, sweet. I'll do the colors on the gauges. So I'll do blue for the compound gauge, red for the high side gauge, and I'll do the
Perfect.
same with the three hoses. So for everybody who's identifying colors on a manifold gauge, it'll be the same.
So what you're going to be doing is you're going to be pulling the refrigerant from both sides of the system here into your manifold set. And then on your charging hose, you're going to go through your recovery machine. So most smaller recovery machines can handle vapor and liquid. It depends on the brand. So just make sure you understand what kind of recovery machine you have. Some of them handle liquid very well, some of them at a different rate. So it just depends on the style and the brand. But that's when you got to pull the manual out and understand your own equipment that you have there too. So the recovery machine is basically going to pump the refrigerant for you. That's kind of the design behind it there. So out of the recovery machine, we're going to go into our recovery cylinder. So basically, it's a little bit different than the push pull because there's not a full circle of the refrigerant that's going between all of the equipment. Basically, what's happening is you have your gauges hooked up to your system and you're pulling it through your manifold, and then it's going through the charging hose into your recovery machine. The recovery machine is doing the work, it's doing the pumping and pushing that refrigerant into the recovery cylinder. And then again, you would want a weigh scale there to kind of verify how much refrigerant was in your system and how much you pulled out, and you can verify that against the nameplate. Maybe you had a leak on your system and you want to see how much refrigerant you lost, then you can weigh it and compare it to the nameplate. And then when you're done the repair, you can put the gas back in and add some more if you need to get it back up to the factory charge. So that's the conventional recovery method there. So a little bit different than the push pull, but both can be utilized on different systems. Typically, the rule of thumb is anything under 10 pounds, you're going to do the conventional recovery, and anything over 10 pounds, you're going to use the push pull method. So you can do push pull method on a standard recovery machine. It is, if you look in the manuals for the recovery machines, they typically give you a bunch of different diagrams on how to hook up in different pieces of equipment. So I have used a smaller recovery machine on a chiller, and it's just not as fast because the pump is a little bit smaller. So I've used a smaller recovery machine and moved 500 pounds of liquid refrigerant in 8 hours. And compared to one of the bigger chiller recovery machines, I could move anywhere from 1,000 to 2,000 pounds in a day, just depending on the configuration and the tanks and stuff like that. So just a little bit different of a process and a little bit of a different time frame too. So
Yeah, and just thinking back to weeks ago, Jake, right? We looked at some documentation on different style recovery machines, ones that are basically dedicated to work on chillers versus the conventional. And as you mentioned, there's a huge difference on the transfer rates when you use larger, more appropriate equipment for bigger applications.
yeah, for sure. So I hope everybody liked the video here. We were just kind of going over the two different types of recovery methods here. And yeah, it was great to come out and share some knowledge with you. So really want to just thank everybody for everything. So
Yeah, thanks everybody. Till next time, I am Julian.
and I'm HVAC Jake. We're out.
See you guys.